A new first for the industry, why a breakthrough from researchers in Hong Kong could speed up the production of semiconductors. Gaining insights into the brain without an actual brain. How a development out of Japan could give scientists a better understanding of neuronal connections. And working towards an energy boost in laser-based fusion, the component a German team is focusing on to improve efficiency while lowering cost. These stories and more on Photonic Spectra Now. Photonic Spectra Now is brought to you by Nifors, advanced specialty fiber processing designed for the highest demands. To learn more, go to nifors.com. And by LightPath Technologies, a recognized leader in providing advanced optics and photonic solutions to diverse industries. Visit lightpath.com for more information. Hi, and welcome to Photonic Spectra Now, covering your top headlines in the world of photonics. I'm Joe Kaczynski, a senior editor with Photonic Spectra. Researchers in Hong Kong are now touting the world's first deep ultraviolet micro-LED display array for lithography machines. But what exactly does this mean? Well, officials with the Hong Kong University of Science and Technology say this tech allows for a more efficient, lower-cost component crucial in the manufacturing of semiconductors. A lithography machine applies short-wave UV light used to make integrated circuit chips. Traditional systems in this practice have been large, provide lower resolution, and use a lot of power. This latest device delivers high power, high resolution, and improved screen performance, all while using less energy. Setting their sights on achieving a sustainable and scalable energy infrastructure, a team in Germany is now working to develop a more functional and cost-effective target for laser-based inertial confinement fusion. With funds from the Federal Ministry of Education and Research and led by Fraunhofer IAF, the IFE Targetry Hub Consortium has already begun their research. 15 members from across the industry have already come together for the 3-year project. They'll be searching for sustainable materials and processes for the target component of this laser-driven fusion. These targets, filled with hydrogen isotopes, are compressed and ignited with a high-energy laser, releasing huge amounts of energy. Heading back to Hong Kong now, where researchers have developed a laser-based artificial neuron. That neuron is said to fully emulate the functions, dynamics, and information processing of a biological-graded neuron, with a signal processing speed 1 billion times faster than its biological counterparts. The new laser-graded neuron could lead to breakthroughs in artificial intelligence and advanced computing. In Japan, researchers at the Tohoku University have found a way to study neuronal connections in the brain without actually going into a human brain. They developed a microfluidic device that helps organize and restrict neuronal connections in a manner that is similar to how the patterns form in the brain. By conducting this work in a controlled laboratory environment, they can reveal how information is stored in the brain in response to various external inputs like visual or auditory information. The U.S. Department of Energy is announcing nearly $180 million in funding will be dispersed between 3 microelectronics science research centers. These centers, authorized by the CHIPS and Science Act of 2022, will conduct research on materials, design, and manufacturing to speed the advancement of microelectronics technologies. And semiconductor company Aeluma is joining AIM Photonics as a full industry member. Specializing in high-performance, scalable technologies for quantum computing and a list of other applications, Aeluma will aid in accelerating quantum dot laser technology for use in silicon photonics, being developed with AIM Photonics at New York Creates Nanotech Complex. AIM Photonics is one of 9 manufacturing innovation institutes established by the U.S. Department of Defense, tasked with advancing domestic production of integrated photonic circuits. Have news you'd like to share or suggestions for our team? You can send any story tips, questions, or comments to video@photonics.com. Give us a like and click that subscribe button in the corner for all the latest videos from Photonics Media, and be sure to follow us on all your favorite social media platforms. Remember, you can always find more details on these stories and everything else happening in our industry by going to photonics.com. I'm Joe Kaczynski, and thanks for watching.